agenda path, which is what we are currently doing. And we'll be doing the RTP header extension for RTP tests done by him, and layer refresh RTP feedback done by me. This is not nepotism, I promise. And then RTP feedback methods for image control, which will be Ronnie presenting. It's a change from the original version on the agenda. And then finally frameworking, which I assume is Suhas, right? Okay, so Mo or Suhas, depending on who shows up in the room. Any comments, changes, anything? Everybody happy? Excellent. So our current working group documents, which is to say our current milestones, they're all, these three are all making pretty good progress. Ben, correct me if I have any of the IESG stuff wrong, but I think I have this right. So grouping taxonomy has been approved. There was a new version with some editorial comments, and I believe it is now ready to go to the, I think it's in a waiting for announcement to be sent state or whatever that's called. Yeah. Stream. What? Yeah. That's.
Oh, anyone can do that.
Yeah. You can get to the IETF, but nobody else. IETF and Google, but nobody else. So stream pause. We did the pub rec. Ben did his AD review. There were some changes, which I think satisfied all the things he discussed for stream pause. And I assume next it will be on the IESG agenda. So you'll go to IETF last call and be on the IESG agenda sometime, but you don't know when because your network is down. Okay. And then spicy notification. We will probably do the start doing the pub rec once the once stream pause is basically not my problem anymore. I don't want to be juggling too many things at once, but it's basically ready for pub rec. So, and our other two working group documents, which correspond to our other two milestones, have agenda time. They're the first two items on our agenda today.
So stream pause looks like we'll respond to my comments, and then we can get through it and make sure we're okay. And then
Okay. Yeah. So Ben said stream pause. Just to repeat, in case the recording is working. Ben said that he needs to make sure that Bo responded to all his comments, and then it'll go to IETF last call. So Ben has the action item. All right, good. Oh, so Ben has to do AD stuff, and Ben knows what his AC stuff is because he's a very good AD. And the final thing, we got a liaison from 3GPP. If the network were working, you could go to this link here. But it's about video region of interest. It's related to the topic that got brought up in the image control draft, which we'll be discussing later. So we will discuss the liaison statement after we have discussed that draft and decide how we want to do things. So that's it for this presentation. So Magnus, you're up first. So yes, go to the pink box. And I believe we do have somewhere here, if you want to do your own, I believe this is a slide clicker, except probably won't work, except probably wouldn't work to my laptop. How does it work? Oh, I see. I put this in my USB, and then in principle, you can then completely control my laptop.
Yes.
Excellent. Yeah,
yeah.
Excellent. Oh, and now my Mac is saying press the shift key on this keyboard we just inserted, which is not going to work so well.
Blue sheets?
I think I will just drive the slides. So
yeah.
My Mac thinks this is a keyboard and wants me to press the shift key on it. All right, so there we are.
No, it should be working on.
I don't know. It said keyboard detected. Press this. What? Oh, well, I didn't. Oh, it's okay. It gives me something to do. All right.
Okay. So I'm Magnus Westlund. I'm going to present the working group item around RTP header extension for session description information. My co-authors are Bo Björman, Ronny Evan, and Mo Sanati. Next. So, short introduction, a bit of the changes. We have one issue around 1 to 2 bytes header. We'll talk slightly on, or discuss a little bit, and then it's the next step. So, let's go forward. Yeah, so the draft's goal is really to define RTP header extension for the RTCP STS information, which makes sense to send the RTP header in extension. So it's been updated twice since Dallas, once in May and once now close to the deadline. So next. Yeah, so the changes for the 01 version, which was the larger update, we make clear that really STS header extensions that's suitable and not really, they are non-suitable STS header extension and shouldn't go into this header extension. So and a little bit about which criteria, which, for example, privacy is one of those. We also removed reference to source name and app ID, as those drafts aren't really progressing and are not work item, etc. So just to avoid having reference to potentially dead things. We have enough about the use case anyway. We also expanded the transmission considerations and about also about RTC information, you can determine that you actually, the receiver has gotten the header extension. So you also have discussion of that, so you can stop sending it, for example, oh, he had gotten it, and things like that. We also discussed how you avoid update flaps. So basically that if the artist, if you're sending out, you're creating an RTCP packet, and at the same time you're sending it, you are in the process of creating it, then decide to switch, but you're already in the way of scheduling the RTCP, so that part of the stack might not react to it, but the header extension goes out and arrives before, and then you're back to the old one for the RTCP, which arrives slightly later. You don't want to flap back and forth, so there's discussion on how you can avoid that. And there's much clarified about the IANA registration and rules about the actual registrations for any future STS items that would like to use these header extensions. Next slide. In the O2, the major change was a new section in a new paragraph in 421 about 1 versus 2 byte headers, and there was a number of editorial changes. But next, so the issue, or so when we put together this O2 version, I noted a bit about that it was unclear about certain things in the in regards to 1 to 2 bytes header. And this issue actually is not specific to this draft. It's there's text in the RFC on the header extension 5285, which basically says a stream must contain only 1 byte or 2 byte headers. They must not be mixed within the stream. And what means when mixed, can you switch? So you can be first using 1 byte and then go to 2 byte and keep on doing that. Is that mixed, or you need to decide already at original first header extension in the SSRC if you're going to use 1 or 2 bytes? This is a bit unclear from the 5285. And really, the header, especially for STS items, this actually is irrelevant because you might start out with 1 value which fits in a 1 byte header because the data payload of the 1 byte header extension can only fit 16 bytes data. And if you actually have an STS item that suddenly is 17 or more bytes of actual content, then you would need to use 2 byte headers, and then you actually would need to switch. And because this information can actually change, we do have an issue here potentially. So.
Mozinati, I think this issue that you found, Magnus, is even more severe than switching between them, because it appears that the 2 byte header is not even required to be supported by someone. So even if you negotiate a header extension and you think you're going to send a 2 byte version of it, the receiver may not do anything about it, and you don't know that he didn't do anything about it. So that's, I think, a severe problem in that, a severe omission in 5285. We probably need to fix.
Yeah. So let's see. We have that's the second part.
Sorry. That's the next slide.
Next slide, yes. So I think the way forward really here is For this draft, we can't do much about this. It's really not specific to this draft. We can note kind of the issues, etc., and what any recommendations about trying to keep the SDS items in line, etc., and try to determine early on what you're going to use. And then, I mean, I think the still recommendation is that primarily to try to use 1-byte headers when you can, because, if not for size restriction. And then it means the other question is really to revise RFC 5285, which would be AVT core working group work. And I think the discussions there would be to first ensure that you really mandate 2-byte header extensions being supported also, because the implementation difference between supporting just one and supporting both is minimal. And then there's a question if one, which we need to discuss then, is to enable switching between 1 and 2-byte headers. So, yeah, comments?
Ronnie, I think we should do this work because, I mean, when we started to have header extension, we didn't envision to see so much header extensions. And now we see more and more usage of header extensions, which makes sense to clarify 5285 and resolve all these issues.
Yeah.
Hi, Colin Perkins. So excuse me. Presumably this draft should needs to say should use 2-byte header extensions since they're the ones that are safe, but may use 1-byte extensions if it knows everything is going to be small. So that should presumably be the recommendation here. And yes, that's just an obvious clarification. Yeah. Should we revise 5285? Sure, why not? I mean, obviously it'll need a signaling extension to say that you support the revised version. But yeah, I mean, it seems like an obvious thing to do.
So Stefan Wenger, deprecate the 1-byte header extensions for good? Is there a lot of deployment of those?
Yes.
Yeah.
Yes. I think, I mean, if you have deployment at all of the header extension, it's definitely the 1-byte.
I'm not sure there is deployment of the 2-byte form.
Mos and Addy, I think a possible way forward is, I'm not sure whether it be in the 5285 update or in this, or maybe even both, just to make sure that everybody's covered. We should advise that new implementations should use ID bigger than 15 for all the 2-byte headers, because then it's unambiguous that it must be a 2-byte header, because
It's already unambiguous. Whether it's a 1 or 2-byte header.
No, 1 to 14 are fair game for 1 or 2-byte headers. That's the problem.
Yeah.
So you don't know.
No, but it's, you know when you
Use the mic.
Use the mic.
I mean, what I'm saying is that you know when you get the extension whether it's a 1-byte or a 2-byte because it has different headers.
Right, but that's too late because the sender, when it's generating it, it doesn't know if the receiver will be able to consume it or not, and the receiver has no feedback channel to tell them that it consumed it or not. So you're sending these extensions and you think that they're valid, but the receiver is just dropping in a black hole.
So isn't it enough to just say that you must support both?
I think we should say in 5285 update that we must support both going forward, but as to work backward compatibility with other things that don't update this, make sure that you always use ID greater than 15 when you're doing 2-byte headers. That way, you're guaranteed that the negotiation itself will tell you whether or not you're going to support whether the peer supports 2-byte.
Yeah, that's at least, it's very safe for once if you're not intending to just, I mean, I think we need to discuss this more because it also depends on switching, etc. But I think what I hear is clear that we should open up 5285 and do a basic version of that and see to clarify these issues. And this draft needs to hopefully do as little as possible. It needs to be able to publish it as soon as possible. We probably should note the issues, etc., and can move on in the publication process while 5285 BIS goes forward in AVT cores. So. Okay, switch of hats. Yeah, I think it's fine.
Do we have anybody who wants to be an author of that 5285 BIS?
I think I'll.
Okay,
yeah.
so I mean,
yeah.
We have both of us.
No,
true, yes.
so.
So what for the madness of order will be right to
Well,
No, not both of us. I think
One
we
or the other.
Mo single. I think we'll stick it on Mo together, maybe with Ronnie or something. The 5285 BIS.
Okay,
Yeah.
but that's not this working group anyway, so
Yeah.
not my problem.
Yeah. Did I have one more slide?
Yes.
Yeah. So I think, except for this issue, the draft is fairly mature. I got some comments from Jonathan in verbal about the flapping text, where I could do a little bit of improvements, but actually I do like reviews of this, and it's not the long documents. It's quite short, easy to read. So, do I have a volunteer?
Well, first, who has actually read the current version of the document?
Okay, 4 or 5.
Okay.
Yeah.
So,
Oh, you don't count.
and your Simon is volunteering to read it and review it.
Anyone else who wants to volunteer to read it and review it?
Anyone else want to read and review? I mean, even if you've, if you've read the current version and think it's perfect, let us know. Yeah, it's very short. It's,
Yeah. So, a little bit about the plan here. I mean, considering that we don't need any elaborate text or waiting for 5285 bis, we can actually go forward after these reviews. Do an update. My hope would be to actually go into working group last call in good time before Yokohama, so we can actually, if we get any issues, discuss them in Yokohama.
yes. And I think there are a number of things that might want to use this, or it's too late for bundle, but
well, I mean, bundle is basic. We're adding on to bundle.
yeah, basically this is generalizing what bundle did effectively.
Yeah.
Ronnie, is our clue document using this? Is our clue document using this? And or should it? I think it should be. So.
Yeah.
No, the
Estes.
IETF93-AVTEXT. Okay, yeah. So there's a dependency and clue on this. Colin?
Hi, Colin Perkins. We should double check and make sure that bundle or anything else, because there was another draft, was it bundle that invented one of these before.
Yeah, did me.
So we should make sure that text doesn't suffer from the problem you identified with the header extension, with the 1 and 2 byte things.
Well, I mean, that's common, so I think it's. I mean, it's really is that we're referring very clearly in this draft to the bundle text about the mid header and saying, okay, here is some.
Yeah, but we should possibly make sure that double check the text in bundle to make sure that it doesn't need a few words adding.
Yeah.
They're basically the 1 and 2 byte header issue. Yeah.
Chris, do love you when he's almost ready for saying he got the all clear the other day on the list, so he's gonna love you.
Okay, so anything else in this document? Yeah, so it sounds like we'll try to, like I said, get a few more reviews and then probably ready for working with last call, in time for them to submit the revised version before the Yokohama draft deadline. Unless everybody thinks it's perfect, but given that I've already given him comments, presumably not. All right. Okay, so good. That was straightforward. All right. And this one.
Try this again, or?
Sure. Oops, which way up is it's the USB problem? Let's see, and let's see. Ooh, it works. Exciting. All right, so this is layer refresh request, which is now a working group document. This is me and everybody else who wrote the VP9 spec, because that's where it came off of. I imagine some of them might be willing to have their names taken off if we discover we've got somebody else's authors on this one, but whatever. Anyway, so changes since the individual draft, not a whole lot. The main content changes is that we actually now have at least a first cut at definitions of how you recognize a layer refresh point for the 4 scalable codecs that we are targeting. And we've also added some more examples of layering structures, of which there'll probably be even more, because as we'll see in this presentation. So detecting layer switch points. H is for SVC. I think this is complete. There's like 3 or 4 different cases. I need some review from people who are reasonably clueful about SVC, which means I'm possibly in the wrong working group, or possibly I should just wander around at my company. But if anybody else has SVC expertise, I don't know how much you, Bernard is volunteering. And Mo, are you writing these down? Or is it, okay, good. All right, 265, I think I have it right for spatial, not that the current version of the 265 payload spec supports spatial yet, because they're just targeting the V1 currently. I assume Stefan has plans to do the spatial extensions, but they want to get the first one done first, which I can understand. There's a flag that says whether or not your streams are scalably nested for temporal, at which point it's trivial and you don't need to do anything for temporal. For non-scalably nested, I don't believe, at least I couldn't find anything that would let me find a temporal layer refresh point, which might mean we have to say must not send for spatial unless H265 goes and defines additional SEI messages, or we start doing something, or we start doing something external like the layer marking.
Stefan Wenger, defining such an SEI message would not be particularly hard.
No, I think it's copying it from 264 probably.
Right. Anyone interested in non-scalably nested temporal coding structures?
Well, the answer is for VP8, yes, as I'll see. Basically, I was somewhat surprised earlier in the week when my co-authors on the VP9 draft showed me their temporal structures of VP8, which were temporally, what I would consider insane. So, so I have pictures of these later. So I think it sounds like, some people think, and maybe
So it's not particularly hard to get an SEI message into H265. So my suggestion is then here, considering the time frame of IETF work vis-a-vis the time frame of JCTVC work, you can safely assume that there will be such an SEI message in an H265 version, in a citable H265 version before this thing hits approval processes here. So I volunteer to do that on the JCT side.
Okay, great. I assume we can just say, Stefan, go do that, and we don't need a liaison or anything fancy like that. Great. Good. So Stefan has the item to do that for JCT. VP8, I think it's just the Y bit, but I need more VP8 knowledge from VP8 experts to confirm that. Fortunately, I think the relevant VP8 experts are my co-authors, but they probably need somebody, to actually tell them to go do the work. They're actually not here, I think. What? Yeah, they both left. So yeah, so I will nudge my coworkers to say, figure out what VP8 is actually doing and how you recognize this. I did not mean to say incomplete. I meant text complete from previous version. Sorry, this is what happens when I do my slides at the last minute. So the VP9, the text should be complete. That's the one we did originally, in the VP9 spec, which then got split out to the separate document. So hopefully it's correct. Hopefully it's comprehensible. It's a lot longer than the others, both because
Mosin, if I recall VP8 right, I thought the Y bit was only for base layer sync. So if you're trying to show switching from layer 1 to 2 or something, I don't think you could use it.
Right. There might be no way to see layer up from 1 to 2. So we might need to say, well, this can only be used for 0 to 1 or something like that. You can tell if there's a direct 0 to 2, you can see. I'll have a picture in a second. So, but yeah, so you can't tell if there's an intermediate step. So you might end up not recognizing some things that would potentially be legal sync points. All right. So anyway. All right, so like I said, I need codex expertise on these things. So if you're familiar with, the nitty-gritty of how coding structures work and how decoders work for these things, please let me know. Like I said, I think my co-authors are VP8. I'll probably Stefan watered out in the meantime. But yeah, so like I said, if you have people who know 265 also, they can review IDEA for 265 and determine whether it's right for the spatial That would also be helpful. I don't know if anybody want to volunteer for that, or maybe I'll make Stefan do that too, or people make people my work. Anyway, but yeah, I think this is, you're just gesturing. All right.
What's the action item?
The action item here is to basically review the descriptions of how you recognize layer refresh points and see if they're correct, and and hopefully complete. I mean, if you have false negatives, it's not the end of the world. False positives are sad. All right. So anyway, so some of these temporal structures, which I was talking about, this is apparently the actual temporal structure that Google at least sometimes uses for VP8, which surprised me. It seemed awfully complicated. So, so this is, so you see that the, which frames, I guess frames 2, 3, and the unnumbered 9 are would have the Y bits set and are thus switch points. So that is, so, I mean, I guess I didn't actually have an illustration of something that would be would not have the Y bit, but would be legitimate layer switch. But this is a case where you need the complexity. Yeah?
Can you just clarify a little bit what the difference is between the brown lines and the yellow lines?
No, because I copied this from the Google guys. This is what? Yeah, no, I just Justin's getting up because hopefully he was involved in this document, in that diagram.
Yes. So I'm a little bit confused what I'm looking at here.
You sent me this picture, I'm pretty sure.
Well, yeah, I know Magnus must have sent you this picture.
Basically, what this is temporal structure of apparently a VP8 stream in at least one instance of the Google encoder, and so you've got three temporal layers.
Yeah, right. Yeah,
I added the arrows, but the rest is you guys.
Number 7.
Do you want to go to the?
Depends on 5 or on 3 or
Both. I believe it depends on both. I believe they're using multiple reference frames.
Right. So yeah,
The bottom is the golden, the upper is alternate.
Yeah, use the mic, please.
Mosenetti, I think this is the bottom is the golden reference frame. The second layer 1 is the alternate reference frame, and layer 2 is the current previous reference frame.
Mm-hmm.
There's three layers of reference frames.
Yeah, I was confused by the blue arrows, but yeah.
The blue arrows are what are indicating which ones are valid layer switch points.
Right. Okay. Yeah, I mean, I think the key difference between this and other prediction structures that have been demonstrated in the past is that here, like, even within just temporal scalability, a given frame can predict from multiple previous pictures.
Right. Yeah. So, and that's what multiple previous pictures, and then across a previous frame of a lower temporal layer.
Ronnie, it was presented in the payload session.
Yeah, I know.
The non-flexible mode, and there was text about it.
Yeah, I know. I copied that from the others. That's why I knew they were doing this, because they put that diagram in the payload presentation. And the other one that was in the payload presentation, which is also complicated, is this. Is this one, which is with the flexible mode, which is similarly complicated, because you'll see here that I guess here the frames aren't numbered, but like you'll see there's the jump up point. Even disregarding the multiple reference frames, you'll see there's a chain of layer 1 pictures, and so the first one is a valid switch point, the second one is not. So this illustrates, and I believe in all the pictures here for VP8, all the valid switch points would have the Y bit. There are cases where a 2-hop valid switch point might not have the Y bit in VP8, but I think probably those are all false negatives, not false positives, so it's not the end of the world. That's just some illustrations of things can be complicated for when it is or isn't valid to switch up a temporal layer. All right, so then any other comments on these structures? All right, so there's a related open issue, what does FIR mean for spatial multi-stream scalability? Does it mean refresh the layer you're sending the FIR for, or does it mean refresh the whole, which term is that in technology? This the whole source, or perhaps the encoded stream and its associated dependent streams if you're doing simulcast. So right now, this question is only relevant for 264 AVC because VP8 and 265 V1 only have temporal scalability, and VP9 is only doing SRST. So at the moment, we only need to figure out what it means for multi-stream SVC. But the spec RFC 6190 doesn't actually say. So do we want to define it? And if so, how and where? I mean, would that be in this document? Would that be another AVTX document because FIR is in the scope of AVTX? Would it be fixing it for 6190 and thus in the scope of payload? I definitely do not want to write a 6190 BIS. Did you have any comments, Stefan? Is there?
Oh, go ahead.
No.
Go ahead. Wasn't there some kind of agreement here in the group already, or not in this group, but I think over in payload, that new video payload formats should have some form of a mapping of what FIR and SIR and all these things mean to the. Okay, so in that case, I think it's an action item for the H.265 SHVC payload, so for the scalable version of H.265 to deal with that.
Mm-hmm.
We don't. Do we have to worry about this for the only temporal scalable version? No, right?
Right. Yeah.
So okay. So the current H.265 payload format is fine. So for the SHVC, I hope I will not forget. For the SVC, there are a bunch of erratas waiting already, right?
Yeah. Well, this is defining
I know.
behavior that did not have working group consensus. So it's kind of
let me talk to Yekui, who did most of the work in finishing up the SVC payload format.
Right.
Maybe we'll ref.
Yeah. There's two questions. There's what do we want the semantic to be, and then how is that semantic actually instantiated for any given codec? I think how the semantic is instantiated for this codec is clearly in the scope of payload, but what we want the semantic to be, sort of in the more abstract sense, is this working group, I think. And I mean, my personal recommendation is to say FIR means full intra request, full intra. It's not just a full intra across all of the layers, even if it's multi-stream, and then use this new thing I'm defining on a single one, targeting a single one of the streams.
Plus one, and I don't even think that's ambiguous. I always expected that's exactly what it meant. Full is full.
Yeah, okay.
Full intro.
If we want to say full is full, and that's what the spec says,
and the spec is the way you do a single layer.
Okay, I'm certainly happy with that. If there's
at least in practice, so there's an IMTC document that describes all of this, and at least in the layer structures they use, it would be immaterial. It would always mean full because it would everything depends on the base layer anyway. So if you send it to the base layer, it would basically mean refresh the whole thing, kind of by definition, right? So there would be, at least in those structures, there'd be no case where it could mean anything else. Yeah, if you look at, I can show it to you. I can look at everything because everything's off the base. If you were right, that's the only thing it would make sense to send the FAR in, but you can look at the diagrams.
All right, yeah. So we've been certainly I guess Bernard to send that to Stefan to double check that. But yeah, if there is no actual deployed usage where this makes a difference, I have much less worry about deciding what it should mean. If anybody was actually doing this, then I'd want to figure out what they were actually doing and how painful it would be for them to change. But as it is, I think, yeah, so it sounds like we have consensus. Now the question is, where do we want to write down this consensus that this is what FIR means for MRST? I mean, it could be in this document. It's kind of out of place. It could be, folklore and rumor, which, probably is not the best option. it could be, you know, a new like 2-page document update to CCM.
Can it just be in this new document and just say this updates 6190?
Oh yeah, it wouldn't be updating 60. I think it wouldn't. Well, I think it wouldn't be updating 6190.
What's the only spec that doesn't have has ambiguous FIR?
I think it would be updating the definition of FIR. Basically saying in multi-stream cases, FIR really does mean yes. FIR means FIR.
Okay.
It's not 4588. It's CCM. Isn't it 5109? 5104, something like that.
It's just weird to update something that may even predate what you're talking about and say that it wasn't clear about it.
Yeah, no, I mean that's why we do updates, right? Because we discover cases that didn't exist. You know, two things intersect that didn't exist, you know, at the time. Justin?
So maybe I missed this. Are we saying that FIR have different behavior for SVC, MRST, and simulcast? It would have different behavior for yes. Basically for MRST, it would mean refresh all the layers. For simulcast, it would mean just simulcast. The two streams are entirely independent. Yeah, I think that's confusing. That it has different semantics depending whether or not there's prediction between layers.
Yeah, I mean the thing is the streams are much more semantically intertwined in the. I mean for simulcast you don't even have to run them at the same clock rate, right? So.
I mean I totally get what you're saying. I just think that it is kind of awkward.
I don't like this because. Everywhere where I go, I tell people that simulcast is just a special case of scalability without interlayer prediction, right? I think we should think that through a little bit more, not making a hard and fast decision here.
Yeah, I mean, so.
Mosin, I think the update should say that FIR should only go to base layers. That would clear it because there's no reason to be sending FIR to the upper layers when your intent is to refresh everything. You should be sending that to the
right.
base
Well,
layer.
but the point is that what that means is, as Justin says, what that means is that then if you send the FIR to the base layer, then it is now after the FIR, all the layers are restarted. It's now valid to start, decoding all of the layers. With simulcast, you send FIR to one of the simulcast streams. The other one has an unbroken prediction chain. You can't start decoding it. So simulcast and MRST are different. That's the thing Justin is concerned about.
I think it's kind of cleaner to just, even for simulcast cases.
You think for simulcast, you want to say FIR to one means refresh of both?
No.
You wouldn't have to, but it may be cleaner in a lot of cases.
Making forward-looking statements here. There is at least a theoretical technology called multiple prediction coding, which is like something like layering, but doesn't have a layering structure, right? And that would have properties very similar for this type of stuff as simulcast. So again, this is hard. This is hard.
I mean, my inclination would be to say, personally, I want to say despite the asymmetry, simulcast and SVC are different. And I think it's, any of the options are ugly, but I think, implicit FIR in simulcast cases is really weird, and, partial refresh. And I want to have a way to say full refresh. I guess the difference.
What if we were going ahead and saying, in a short document somewhere, saying the semantic of FIR is per layer, per non-temporal layer, period. However, the sensible thing to do if you are really doing layering is to send FIRs for every single layer you have. Right? That way we would be future-proof and spend a few more bits.
Oh, so basically say that, FIR and LAR mean the same thing, but you should always send an FIR for all the layers in the same compound packet.
Right. Because the ITR says that, ITR says that you cannot doing a prediction on previous pictures. So that
Right.
means that you need to have on layers that you have dependencies on.
So go to the mic.
Bernard about myself. But if your prediction only depends on the base layer, why would you be sending it to layers that you don't need to send it to, right?
I mean, you don't. I mean,
Ronnie, please use the mic. I would like to make a suggestion here, I think, to make forward. And I think you actually need to write some text and take it to the list to try to figure out what the issues are, etc., and how. Yeah. You need to go think a bit. Yeah. Go ahead, Justin.
I just have one simple sort of, maybe this was shot down, but like, is it not okay to say FIR is per SSRC and LIR is per like layer?
well, the point is in the MRST cases, they're the same thing.
I understand, in which case there would be idempotent.
I guess so. The argument, at least for the MRST case, if you want refresh for the whole thing, send FIRs for the whole thing. For the MRMT cases, that's a little harder because you're not sending them the same packet. But I guess you could still send them. You're sending one in every session.
Yeah.
I mean, they're not necessarily in sync, which is annoying. But
I mean, I feel like that's the simplest thing for like my brain to understand. Like I can't speak for the rest, but I'm like, you know.
Yeah. All right. So okay. Yeah. So it sounds like an action item on me to write up some suggestions to the list for what we want to do. And you have that. Somebody has that noted down that I'm supposed to do that. All right. And I believe this was my last slide. I'm glad it wasn't just another. No, I'm glad it wasn't a boring discussion. It's always nice to have something useful to talk about. All right. So I guess Ronnie is next. Oh, here's the. I won't do anything yet.
Okay, so RTCP feedback message for image control. It was written by myself and Rachel. How do you make it progress? Okay.
Stay on axis on the mic, Ronnie, or
yeah. Okay.
Yeah, or pick it up if you want to face your screen.
That would be. Okay, I'll go this way.
Too high for you.
Okay.
Just be a rock star. Pull it out and hold it in your hand.
Okay, thanks. Yeah. So the motivation is to get a detailed image of part of a picture. It's maybe preferred by user in some applications like monitoring, video conferencing, telemedicine, which was the very original request for doing far-end camera control, mostly because it was for you. Telemedicine typically was something that you watch someone doing an operation from remote, and if you want to concentrate on part of the work, you don't want the guy who's doing the operation, the doctor, to change the camera because he's doing some other stuff at the moment. Now, in our case, it can be done by the receiver. For example, if you're displaying an SD or a VGA image from a received 4K image, you can zoom to any size because you have more information that's really being displayed. You're even doing scale down to display it on the monitor. But in some cases, you want to do it by the remote side, using, for example, camera zoom and move or digital or whatever way it can do that. A conference bridge may require different view for each participant, for example. Next slide. Oops, sorry, going back.
Wrong way.
Okay, so currently there's H.281 which does this, but H.281, the way it works is the feedback is done, basically you say zoom or move, and the way you see it when you see the image that you receive, then you decide whether it's what you wanted, and of course because of this look back, which depends on what you see, and you don't know when you press the zoom or move how much it will be, it's not very accurate, and it causes people to move too fast. So what we're suggesting is to have a new RTCP feedback message to signal the area that the receiver requests to enlarge. The specific area is a rectangle indicated by the coordinate of the upper left and left point and the length and width based on the pixel of the current picture sent by the sender. The new picture may display information outside of the current view, which will require to move the camera or to zoom out, but requires consent of the sender in order to really to view something which is in the current view. For example, in this case, in this example, then let's say he wants to view this part of the picture, but the window he wants to view may be here or here, comparing to the current picture that is being displayed. In terms of the user interface, it's something like you draw some rectangle on the screen. You say, I want to see this area, but you can say, I want to see area which is outside of what I'm currently seeing. Okay? And that is why the reference is based to the current picture, the coordinates. So this is the image control request. It will have the top left coordinates and the length and the width, and a sequence number which says this is the current request that's being asked for. And there may be a notification message from the sender that says I acknowledge that I did it, and it may and translator may for the ICN may need to delay the ICN until the ICRS sentence has been responded to.
Hey, Ronnie, real quick, back on the 2 slides back. One more. Yes, on the when you're giving the region of interest, we've done this before, and we found a lot of problems with doing absolutes. We found that really the only good way to do it is with relatives. So, especially if you're doing this like in an environment where the resolution may be changing, sources are switching, or rate adaptation or something is changing. So maybe it's worth considering having those be relative numbers.
So the idea is to have pixels based on the current view. So if you know what your current view is and you saw it, then you can do it. By current view means that you have the information about what is the current view should be the information that you received from the other side.
Right, but I took this to mean that your X, Y, length, and width are in pixels, absolute pixels.
They're not absolute pixels. They are pixel relating. The pixels that should be related to the current. I understand what you're saying, but they should be. But if they should not be absolute. There should be some. They should have some information based on the relative one.
Like if you're getting 4K and you say, okay, I want to go in, 2,000 pixels in, and the resolution drops to 1080p while you're sending that message, then then all of a sudden. Sequence number. No, how would the sender know that this is for the 4K or the 1080p version that I was sending? So we did something like this and we ran into the exact same problem.
No, I understand.
So we moved to
this is the thing that we need to understand and to finish to explain better about what you mean by this information.
Okay, Randall Jessup asks, he says, the current picture leads to some confusing cases and race conditions, I suspect. Would it be better to always have it be relative to the source image, full? Resolution may change frame by frame and may have changed before the receiver generates this.
So this is a good question, and the question is we thought about in the document we wrote original picture, but we couldn't understand what is original picture. What does it mean? I mean, when I start a call, I may get something which may be even a slide and not really a picture. So what is the original picture? And that's why we said it should be based on some current picture. Maybe one way to address it is to try to define a reference point by the receiver saying this current picture is my reference by which I'm referencing, and provide it a number and use it later. So it may require more exchange for that.
So the coordinates and sizes, the coordinates are unsigned integers, right?
Yeah, they can be negative.
They can be negative?
They can be negative because if you go outside from your current view, if you want to go outside to enable the move. It's mostly if you are zoomed in and you want to zoom out, it will be negative, basically.
So Stefan Wenger, I think one useful addition would be to add into this thing a reference to what you guys call the original picture, which could be the RTP timestamp of that original picture. Please don't use the RTP sequence number of 1 packet in that picture, because there may be multiple pictures in one packet. So, but just a timestamp that should solve a whole bunch of problems.
So we need to define something which we call the reference picture, not the current picture, not original, the reference picture to which we're referencing.
Oh, please don't call it a reference picture in something video coding related.
Okay, but it's not original because it's we don't. Okay, we have to define a term for that, which will explain what we are referencing in that.
So from Randall, these could be made floats, 0 to 1 of source width, and be relative to the absolute source.
Can you repeat it?
These could be made floats, 0 to 1 of source width, and could be relative to the absolute source.
Sure, okay. Okay. So, okay.
There's a delay, right, when someone's typing.
Okay. So, there was a liaison from 3GPP where they said that they defined something called region of interest in 26114D00. We were not aware of this 3GPP work, and they also defined a feedback message, but it was not yet even in the IANA registry. So I looked at this document, and it's very underspecified. It has some information about saying it has original picture. The first display, it's not clear what is the original picture in this document, and it's always positive, so it doesn't support any move or zooming in or zooming out or from where what is the original picture is. Okay, because for example, original picture can be a zoom down of some person in the room. Okay, and you want to zoom out, so it's not clear. Yeah, go ahead.
Well, I had two questions, but they weren't about this slide. They were about previous, or in general.
Okay.
So that it might be better for a little later, or
earlier.
Sorry. Well, you want to talk?
Okay, so I'll just finish this slide and then we'll open, because this is the last slide. So when finished, then we can have the question. So we suggest adding support, allowing receiver to keep current views for later use, so they can be used to display back to some other. And the 3GPP has a sender side predefined and not a receiver side predefined. And we look at having the actual view description in ICN message and set it as an RTP header extension. I'm not sure if it's important, since the new view is as seen by the viewer itself, which means that I ask for some view and you can tell me what you are sending me, but I already see what you are sending me, so I'm not sure that you need this information, but at least they had some way to do that, because that's like saying we didn't send you what you wanted, we're sending you something else in the 3GPP document. And okay, so that's what and we need to look at how to do it with 3GPP. We need to cooperate and find a way to do it. I talked with Gonzalo, and we'll need to draft something and to decide what to do with that. Yes. Okay.
Okay. So earlier it said it was a control message. Now this might just be my ignorance of all the different feedback messages, but an RTCP feedback message, is it normally used for control purposes? Is that a normal thing?
Depends what you mean by control.
Well, I know it's a control, but this is feedback. So
okay, you have such. I mean,
is that normal?
You're doing fear for. I mean,
okay.
There are. I mean, from the CCM, there are commands that are really control. Like fear is a control message.
Okay. So in those other cases, do they have a common mechanism for handling when a packet gets dropped? Or does every one of them handle it separately? No, okay. A better question is, for this message, how do you handle a packet being dropped?
Which RTCP or?
For this packet? So there are two ways. One is to get there are two ways. First of all, we defined also, we defined a message, a response message, okay, which acknowledge you. That's the ICN. The other way is, of course, you see what happened. I mean, when you want to zoom or move, you see what happened. What is the result if it happened or not?
Well, you wouldn't know
But
if you had just shifted it. But okay, there's an acknowledgement message.
Colin Perkins, there's a standard way of doing this for the codec control messages, and I'm assuming this is just reusing that.
Yeah.
Standard.
So was that
A convention?
There's a standard convention.
Yeah.
okay?
But notification message.
Notification.
So that was.
So that was the
I'd like to know
notification.
about that.
This one was the notification.
All right. So my last question is, are you referring to the stream that you want by SSRC? Or how are you referring, if there are multiple streams, how are you referring to the one you are talking about?
That's like every other RTCP message. I mean, you have the SSRC
Okay,
inside.
so then
It's
if
part
you're
of
doing
this.
it by SSRC,
Yeah,
then,
because that's how it's working.
then how do you handle cases where, you know, the SSRC might be changing? Do you just resend what you wanted whenever an SSRC changes?
What does it mean, the SSRC changing in
Like
when
you're receiving from a middle box that changes the SSRC.
So I'm receiving a new stream, so I have a new view.
So then you would.
I'll have to. I mean, the request is based on something. The request is based on the SSRC that I send. I mean, that's.
Or in the case of, like we were talking about earlier.
So you did. There's another question that you didn't ask on that on the multi-point case where you're switching, is that when there are multiple participants, then all of them can ask for Zoom at the same time. So we are using in current solution, they are using something like BFCP in order to do token mechanism to provide the right to control the remote camera. It's an application level thing.
Okay.
So it depends how you find it in the application. You need the message to do that, but in the multi-point case, you need some way to allow to define who has the right currently to control the remote side. If there are multiple people seeing the remote side, you don't want all of them to switch back and forth the camera. So it's a policy in the token mechanism to control the remote camera.
Okay.
So Stefan Wenger, completely unrelated to the previous speaker. One thing that's underspecified at the moment, I think, is inside video bit streams, you can have nasty things like overscan and crop windows and stuff like that. So I think what you need to also say is whether your source window relative to which you define your region of interest is with respect to the decoded bits of the video bit stream, or with respect to those decoded bits of the video bit stream that are meant for human consumption. And I assume it's the latter.
Yeah.
So keep that in mind. Thank you.
Okay.
Ben Campbell, referring back to the liaison, two things. Oh, you made the comment they hadn't registered their parameters with IANA. I think, and Magnus, correct me if I'm wrong on that, they actually sort of have what's being held up behind the fact that we don't have an expert for those registries yet.
Yeah, no, it was just my excuse why we wrote it, and we didn't know that something like that exists, okay, because we didn't see any hints.
That doesn't mean they did it in a time.
No. I'm just saying it was just my excuse to say why I wrote something which someone else also did in another organization.
The other thing is that if we have good reason to continue along a path that is divergent from what they've already done, then we need to think about in terms of is there harm done by having two different ways of doing this, and also how we would like to respond to that liaison.
And I think so. I read the document that they have, and all the questions that were asked is about what you really mean by that. They are not there. I mean, it's just some message that says you send this message, and you give the information based on your original picture. I didn't know what to do. It's so underspecified. So I think we should liaise with them and try to figure out what to do with that. But I think that's up to chairs and to the AD to discuss.
Yeah. So Magnus Westlof's share. I mean, I think the reasonable thing before we start any work here is actually to feedback the criticism we have and try to get us, okay, we got this proposal, we looked at what you've been doing, we see some shortcomings based on them, and say, okay, and ask them if they're gonna address it, or if we should basically address it.
Do we know if that's in a actual released version?
It's in the release 13 approved documents.
Yeah.
So, but I mean, they can fix it. That's it. they have a process for fixing it in.
You want to talk about
But-
the liaison? You talk
Yeah.
about liaison stuff on?
Yeah.
I just wanted to say what Marcus just said. FreeGPP can fix things anytime they wish, and they do it regularly. So.
Two different points, but I think they're pretty related. Number one, I think, can you get back to the ICN message, the feedback message? The notification response, yeah. I think would be useful here. I thought Stefan was gonna mention that when he started, but he's actually talking about something else that actually complicates this even more. I think it'd be useful in this ICN message if the sender gave the viewport, the current viewport. That way you know what the original picture size is, and that way you know what the ability to send another ICR message. You know the bounds of what the ICR message can say. So, and then in the multi-point case that you brought up, I think it's very underspecified to rely on some application level thing. To me, the semantics of this match very well with Timber. And so if this ICN message had the exact same semantic as Timber, you provide the bounding set. So all receivers will see this is the current viewport and this is the max original picture size. And here's the bounding set by this SSRC. This SSRC owns the bounding set or the restriction. Then it's very clear in a multi-point case why that is and what other receivers may be able to do to change the viewport. And you can define the semantics of who wins. Is it, most restrictive or least restrictive? You can define good semantics for it. And you could just jump into a meeting. You could jump into a stream and you could know that there's a possibility to zoom out, where otherwise, how would you have any idea that what you're currently receiving could be 4K, not 360p?
Okay, makes sense.
So channeling Randall again, we already dynamic resolution scale on bandwidth and CPU load in Firefox, and we'll do more of this. So using non-pixel based values is a win. And against the absolute source makes it easy to implement, no memory of sizes, etc. needed. Also, it avoids confusion dealing with layered encodings.
Okay.
Jonathan, so I guess the question is, am I speaking sort of as an individual, which is that my inclination would be to say we're better off fixing, helping them fix their message rather than having two potentially incompatible ones, if they can. Even if it has some shortcomings. Colin?
Yeah, Colin. I think you're well into the uncoordinated protocol development considered harmful category here, right?
Yeah, exactly. Yeah. So, so I guess the other question is, the other thing that was mentioned at the chair's training is that liaison, trying to coordinate via liaison statements doesn't work well. What works well is having the relevant people go to the other standards meeting. So I don't know if Huawei is a 3GPP member. They are. So I think that the sensible thing might be if Rachel and Ronnie can just go to the relevant 3GPP meeting and help them fix the thing so it behaves correctly. We can do both, yeah. But I think so possibly the thing to do is write up any liaisoning stuff. So I'm kind of just going by what I heard on Wednesday plus rumor. But
I wrote a liaison already the previous meeting, so I can provide you the structure.
Or perhaps since you're the one who knows what the problems are, you could provide the text of the liaison statement, and then I would approve it.
So let me plus one sort of that direction. I think you're right that you need the people there to catch the liaison when it arrives.
Yeah.
But I promise you, from being at both ends of this, that if they have the liaison, it helps give force that people should pay attention to the comments that are being argued in the thing.
Mm-hmm.
So
my inclination would be we write up a liaison that says these are the shortcomings or unclarities that we've seen in this spec. If these can be cleaned up, we are happy to let them take finishing the work.
You're way overthinking this.
Okay.
The liaison needs to say, we love the incredible great things you're doing, but note there might be even better things if we work together. Done. Okay.
The problem will be with the process. Okay, it's like you said. It's like if you heard here the comments that were made, I'm not sure what happened there because it doesn't, the way that it's specified there doesn't look like people really paid attention to what they were saying there.
Use the yeah. So yeah, unfortunately, I don't think there's any of the relevant 3GPP people here right now.
I think that
I think it's If only we had Keith. Keith isn't in the room, is he?
Can you just a question? I think you should ask if people think that this is something important to do at all, and we should try to cooperate and work. If it's not important to people, then we let them do whatever they want. I mean.
Yeah. So okay, we can. Yeah.
Yeah. If we care about it in the first place.
Yeah. So let's ask that question first. We start with saying, who are in this room are interested in a good specification for these functionalities that's been described in this presentation? Can you show hands or indicate? I mean,
I suppose you wouldn't use it whether it was good or bad. Yeah. I mean, if it,
That's weird.
I suspect some of our video surveillance people might use it, but I haven't confirmed with any of them. But if I had to guess, I'd guess that direction.
Well, I mean, I think the working group anyway needs to send a license back, and I think they should include some feedback on this. So,
nobody except Colin had a maybe, but he doesn't know.
Yeah.
And nobody else, and Ronnie obviously.
Yeah.
I mean,
Bo, are you doing a maybe also?
I think I have to.
By the way, does anyone do real system as a remote zoom, remote far and camera control?
Yeah, but that's just
all of them using H.281 and they're happy with that. So if you're not happy, then we need some solution that's not H.281. I mean, that's what surprised me. I mean, that people say they don't have interest. I mean, I've been in video conferencing. This is a major problem. H.281 is not very well user interface for that. So that's why I was wondering about it. I was surprised to see that.
Bo Berman, I'm just saying that although I'm not into that explicitly, I think it would be feasible that we got it right in 3GPP. So I'm actually interested to kind of help them. Yes.
So you could be the person who catches the liaison statement on the 3GPP side, or the like.
Myself or a close colleague.
Okay.
That goes to SA4.
Yeah. Well, that's a.
So Stefan Wenger, before you guys beat up poor 281, that thing is around now for what, 15 years? So far, the complete video conferencing industry and the complete surveillance industry has not found a real reason to replace it, right? Let's not forget that. We were all bitching and moaning over it, but you know,
it's awful, but it works.
Well, it's easy, and the one thing not to forget: this stuff, generally speaking, is all based on eyeball feedback loop, right? So what H.241 is, you press the camera tilt up please button on your remote control and the camera starts tilting up. Yeah, you don't need a per pixel exact granularity how much it should tilt up. In fact, from a user interface viewpoint, it wouldn't work that way. You only need the information, please tilt up. So now, when those guys come up now and say their application where you need a per pixel granularity of telemedicine and whatnot, great, let them have it. But it's just don't mix this up with poor 281, which works just fine for the purpose it was designed for.
Yeah. So the 3GPP spec actually recommends both 281 and this for different circumstances.
Yeah, I think H.281 is actually more like 1992.
Yeah, and looks like it.
Over H.224, which is HDLC.
Well, I mean the original H.281 goes back to 1992.
HDLC.
Yeah. My former company, PictureTel, actually drove that standard, for better or for worse. We also attempted to replace it around 1998 with H282,
Yes,
which was recently deprecated because there were no implementations.
that was the one that had the one that had the turn on the windshield wipers.
Yeah, but that was based on T120
It was
stack,
but it was available also if you weren't running T120. So, yeah, there might be a need for a better foreign camera control protocol, but so far I would agree with Stefan that the obvious attempts to replace it haven't gotten the uptake you might expect. So, hence I didn't express a huge amount of interest.
I can say that there were some implementation that tried to do it with the user interface by displaying some window on top of the window and trying to do that. And you
we're getting kind of short on time, but we probably should. But yeah, so it sounds like the consensus is we should write a liaison statement and see what happens. Sort of giving, and Ronnie, would you be able to do an initial draft of that for us? All right, so Ronnie will write an initial draft of the liaison statement to respond to 3GPP, and we will have a few people who are there in 3GPP to do this discussion and get this hopefully get this into shape that satisfies the needs that be specified to everyone's satisfaction. All right, that's all right. So next, finally, is I have to switch. Suas or Mo? Mo's got it. All right. And Ronnie, did you walk off with this? Oh, no, it's there. Okay. All right. So, and this is PDF. So I will need to. Let's see. There's a way to do. How do you do full screen?
Probably.
Yeah. Yeah. Oh, that's exciting. No, can I know it's
Interesting.
Okay. This is a preview, not actual.
Testing.
So, is there a button here that looks like it might be? Full screen. There we are, after full screen. Perfect.
Yay. Okay.
And I don't know if the button works with preview. You can find out.
Okay. I'm Mo Zanatti, presenting on behalf of co-authors Espenberger and Suhas and Kumar. This is a video frame info. It's a proposed RTP header extension. Next slide. So a quick recap of the motivation. There is a growing need for having payload agnostic RTP switching. And by RTP switch, we mean all of the topologies in the topologies draft that relate to not being able to transcode media. So things like the media switching mixer and the selective forwarding unit, SFU and MSM. We just abbreviate them as RTP switch here. So the main reason for that is that the payload may be encrypted, and there may be a desire for performance reasons to avoid decryption of the payload to extract the key information that you're trying to find, the important information that you're trying to find out, usually in payload headers. A lot of codecs define some early bits in payload headers that are very useful for switching functions, or stream identification or bit stream identification functions. So that's more just a performance improvement to improve scale. But then PERC adds a new twist to that. The payload may not only be encrypted, but it may be end-to-end encrypted. So the middle box may have no way to decrypt it and see those payload header bits. And so with PERC, this elevates the need for having some kind of functionality like this. And then finally, Bernard brought up a good a document that illustrates the last use case. You should be able to design middle boxes that don't really take a lot of impact for new codec formats, and even potentially no impact at all. You may be able to maybe even future-proof some middle boxes by supporting generic codecs in the future if they follow this certain header extension. So what you're able to do then is do all of your processing in the middle box in a payload agnostic way, support any codec that comes along, as long as you have these important bits in this header extension. Some more motivations, kind of secondary, but the switch can do smarter functions. When you look at things like resilience, a lot of times it's useful to know whether or not packets are at the start of a frame or end of a frame, so you can identify leading loss versus trailing loss cases, and it really helps to improve the recovery requests that go back to the original senders. So you can get clean video switching at iframe boundaries if you have some of this information. And when there's packet loss, you can recover faster and better and more accurately. You don't need to request packets that would be useless to recover anyway. You drop the least important packets during congestion. So the switch is acting like an intelligent router. It knows which video frames are more important than others, and it can drop the ones that matter the least. And for scalable codecs, you can drop entire layers, not just for congestion control, but for capabilities, different capabilities of different devices. You can send one guy, 360p, send another one HD, and you can do that function pretty easily. And then also, not just the switch, but you could also take advantage of this for the endpoints. Smarter endpoints could take advantage of the starting and ending bits that we'll show later to have better recovery during packet loss. You can have more intelligent decisions about recovery operations. Okay, so the changes. The feedback we got on the draft was that people didn't like, the original draft had a fixed mandatory part that was codec independent, and then it also had a blob, a codec specific blob at the end, a variable length blob. People didn't like having that codec specific variable length blob at the end. So authors agreed, and we did a rev, basically removed the entire optional codec specific part, and now it's just a fixed header extension. But there was also feedback that they wanted more of the scalable information in a generic way. So there was a request to get all of the scalable codecs somehow harmonized into some common header extension. So we took a shot at that, and that's what the new layer ID field that's part of the header extension has become. And we defined the usage of that layer ID field, the meaning of all of those bits for all the current codecs. For that subset of codecs, 264, 5, VP8, and 9. And there was also a question about IPR that may read on this, and we verified from video that that there's no applicable IPR.
Well, no applicable IPR of which Stefan or I are personally aware.
Okay.
Okay. All right.
Whatever there was on the list. So
no IPR which Stefan or I are obligated to disclose in this context.
Okay. Yeah. And so there was an email on the list. Stefan sent an email on the list. So if anyone wants more clarification, that email should tell you exactly what the IPR situation is. Okay.
I am telling you what I can actually promise.
Okay, so the actual extension is as it shows here. The bold is what's different. Before that bold part was a codec specific blob, and now it's become a layer ID.
The bold is sort of invisible. So you mean the LID?
Oh, I'm sorry. Okay, so the far right, the last byte on the far right.
All right.
So the last byte on the far right, the LID, layer ID, that's what's new. That used to be a codec specific blob variable length. Now it's just a 1 byte layer ID for spatial and quality layers in scalable codecs. The rest of the header extension is as was defined in 00. You can see what all those other bits are. Notably, I think that B base layer sync is what Jonathan's presentation earlier was talking about with the VP8Y bit. So some similar functionality there. Okay, so going on to the example of what that layer ID looks like for the different codecs. So because all the different codecs have different semantics and bits for their spatial and quality layers, we can't just have one single number that means something common across all the codecs. But we define what the individual bits are for each codec. So for 264, there's the DID, which is the spatial dependency layer ID, and the QID, the quality layer ID. And those are 4 and 3 bits, and everything is padded with upper bits of 0, leading bits of 0 if they don't fit in the byte. H.265 has a 6-bit layer ID. That's a combined spatial and quality layer ID. It's a flat space in 265. VP8 does not have spatial or quality layers, so there's nothing there. And VP9 has 2 bits of spatial and 2 bits of quality scalability, so they're defined there. And one minor tweak that we batted around, and we leave it to the work group to decide. If you, like, for example, VP8, it doesn't have any need for that extra layer ID byte because there's no spatial or quality scalability. The header extensions all encode a length anyway, so we could omit the last byte of layer ID if the codec doesn't actually support spatial or quality layers. So that's a minor tweak that get work group feedback on. Peter.
So the original purpose is to have a middle box or a forwarding unit that doesn't need to do codec-specific logic, right? But in this case, it still does need to do some codec-specific logic, right?
If it wants to operate on spatial and quality layers, there is no, there's no good way to get around it, because the biggest incompatibility is the 265 break. 265 breaks the separate quality and spatial layering. It's a flat space, so there's really no way to reconcile that flat space with the separate spaces of other codecs and have an identical meaning, a single number meaning. So there's really no way for the middle box to completely avoid knowing the difference between spatial and quality layers.
Is it a situation where, like header extension IDs in the first place, where a particular ID, you give it semantic meaning via signaling? Is there something similar here where you can say, okay, for this stream, here's what the semantic meaning is, that doesn't necessarily require the middle box to go and check the payload type, but rather it would...
I can't see how that would be any simpler than a payload type. I mean, the payload type, the RTP map will tell you what
in the future, as we add codecs, every single time we'll have to...
okay. Maybe it's useful to think about, for new codecs, do we want to define this in a single way? Maybe follow 265 example, all new codecs just use a 6-bit layer ID and be or 8-bit layer ID and a single number and be done. We could think about having something like that maybe in the RTP how-to about how to design new scalable codecs.
Like pick one and say, please use this one in the future.
Right. But for current middle boxes, I think it's unavoidable to have a little bit of knowledge if you want to handle spatial and quality scalability, which, by the way, I think are very rarely, if ever, deployed. Quality, definitely very rarely, if ever.
So, Stefan Wenger, thank you for addressing the concerns I had at the last meeting. There are, of course, additional concerns. There always are. There's stuff that's missing here for at least for H.264 and H.265, and arguably also for VP8. All this temporal scalability support stuff that's useful, right? That's implemented and useful. TL0 ref pick index, stuff like that, right? So that's number one. And I actually have a design suggestion. This exercise reminds me a little bit on a discussion we had back when we did RC2429 H.263 plus payload format, where we were trying to define a payload format for a codec that wasn't fully specified, which has a super complex picture header, and the original proposals tried to match bits and try to do things and replicate stuff. And at the end of the day, we said, let's try to be future-proof. And let's try just to say, okay, you grab the first n bits or bytes of your packet, right? So say of the RTP payload header plus the slice. You just grab those bytes and copy them into your, in this case, header extension. We did it at the time for a different purpose. We needed a redundant copy for error resilience, but we just grabbed some stuff and copied it, and we were done. And it was future-proof for two future versions. So, I mean, it's a quite radical design change from what you have here. But think about that, whether that may be a good solution.
Well, the only The only problem I have with that is that, one of the goals is payload agnostic switching, so that
doesn't work. Just doesn't work. Doesn't
completely
work
go in the
even
opposite
today,
direction.
right?
Well, but for all the other things, it is working, right? For all the other bits, it's only the layer ID that it's not working. And actually, I don't really know of any deployed interoperable system that uses spatial and quality scalability. Period.
Oh, actually, I do, but
not video to video.
So
that's not considered interoperable.
That's come on, don't be so. Anyway, well, maybe, but let me at least make that final point, and that is, whatever those first couple of 24 bits 16 bits are that we have at the moment, which you think are sufficient for the non-scalable stuff, that may be the case today, but this approach is not a future-proof approach. And I tell you, in a few years, someone may dream up a codec where they need 2 more bits to do something like this, and that half-baked idea which it just threw into the room, on which I can tell you video does not have IPR at this point. That particular idea, nor has Technical University of Berlin, nor has Intel to the best of my knowledge. That particular idea can be made future-proof based on previous experience.
Yeah, so I agree that the newer features of newer codecs will be hard to figure out any kind of way to standardize them. And scalability is spatial and quality scalability is a relatively new feature, and that's why I think we see problems in that area. But I think the old stuff, is probably pretty safe. The first byte of that is probably pretty safe, that we can rely on most codecs going forward. And actually, some of them are even RTP things. They're not even codec level things. Like just the start and end bits. Those are like just basic things in RTP that are not broken, but missing, that are oversights that didn't have the foresight to think about what resilience cases would be complicated by not having them. So really just fixing RTP level things.
Jonathan Lennox as an individual. I think you would certainly need TL0 pick index for the resiliency things. The
TL0 pick index.
TL0 pick index. The other.
That's all.
Yeah, for all of them. For anything temporally scalable. Otherwise, you can't tell. It is in all of them have it, but with slightly different semantics, which is annoying. So the other thing is, if you actually want to support all the spatial stuff, you're going to need something, possibly stripped down, equivalent to the VP9 scalability structure, scalability update, or the H.264 equivalents, which are even bigger. And maybe you don't need the description of what the layers mean, but you at least need which layers you can be expecting to receive at any given time. Otherwise, you don't know when if you've actually gotten the entirety of the full frame with all the layers you should be receiving.
Yeah, that's a good point. So we don't talk about the announcement of the layers here at all. We just talk about
but
the delivery of them.
If the point is something where the codec-specific stuff is invisible, you need some way that the layers get announced in a similarly codec-agnostic way.
Do you think that should be in this draft, or do you think that's separate work?
I don't know. One possibility would be have this draft just address what temporal needs and forget spatial for now, because the temporal is better understood and simpler.
But I think your announcement point is still valid even for the temporal.
Even for temporal, no. For temporal you don't have the same knowing when the frame is done problems. So I think that might be easier. The other thing I was going to say is, if we do keep these layer IDs, we could certainly arrange things so that the way that the layer IDs are defined here and the way they're defined for LRR are the same, which helps some of the future-proofing case. Basically, you don't know what it means, but you copy it from here and put it there. Or you see it here and it means that. It means that one is happy.
I agree, that would help.
Yeah.
Not about Microsoft. I just wanted to bring out the point on the TL0 pick index. I think it's worth talking about a little bit more, because it isn't universally used, but I guess the folks who do use it are vehement about it.
Yeah, I was going to take it up on the list because we only had 2 minutes left, but I have a very large. I think I have a large counterpoint that this is really more in resilient strategies, having different resilient strategies, and deciding whether you want to have RTP-based resilient strategies or codec, source-based resilient strategies. That's a bigger can of worms that I think that we can discuss. But I hear the camp that wants codec source TL0 type resilience, and we can figure out a way to add that. So last slide, next steps. I suggest that we should have a milestone for this. There's clearly needs in PERC and AVT Core. Bernard wrote a good document really motivating what middle boxes can and can't do and why they would need something like this to do their functions. And of course, in the PERC context, it becomes critical for a lot of uses. So I'd like to see it adopted as an item.
Any responses or feelings about that? People generally think we should do this, shouldn't do this. I guess the usual questions: how many people? Well, first, how many people are either have read this document or think they're at least recently familiar with it? Decent number. How many people think this is a topic that would be useful for the IETF to work on? At some point, he said. Okay. Does anybody feel like this is not something we should work on now? Yeah. Stefan does. Okay. Why?
I don't mind if work continues the way it has started. However, I think this whole selective forwarding unit architecture issue that Bernard raised in AVT Core, that has to be thought out. Yeah, all these bottom-up, trickle-up mechanisms like this particular draft, fix a tiny problem first. That takes us only so far, and we have made enough mistakes with respect to RTP extensions in the past. So unless you really absolutely desperately need it tomorrow for your product, I would say let's take half a year and think about architecture first before we go and do something like this.
I think a lot of people have proprietary implementations of something like this already.
Well, exactly. That suggests that we don't need it yesterday because we already have a proprietary implementation.
We'd like to get to interoperable implementations.
In fact, there are multiple proprietary implementations of this, which actually speaks for why it's be good to have a standard, because it means it's desirable enough that if left alone, it will kind of spread in a million different ways. But also having a very specific case is a good way to understand the architecture better, because everyone will argue about things as we just have, and we'll learn something as a result. And that will help us understand what the architectural issues are.
So, Stefan, you think maybe if Bernard's document that kind of describes the overall use cases of and operations of the SFU, of these switching middle boxes, would be the right place to document your more holistic vision of what needs to happen? And this draft just covers, the specific technical solution for the part that that needs metadata identification, and that's it.
Absolutely. If there were already a framework or an architecture document, this would fit in perfectly to solve this particular problem. Perfectly, I don't know. Maybe there's a better solution like the one I outlined, but it would fit in, right? No problem with that. Are we missing something big here? That's my question. Are we missing something big? Is this just a patch to a specific product design where we should actually do something completely different somewhere, right? And frankly, I don't know the answer, but that's why I said let's take a step back, take it easy for a while.
Okay, so I'm on the other end of this side of that. We understand the architectures fairly well in this. Between the people in this room, we've built several different instances of it, none which are interoperable. And the way we kill stuff at the IETF is by studying an architecture and requirements document to death. I mean, Clue would have succeeded if we'd just done it instead of studying it for 2 years. I think this is another great case where If you work a year on an architecture document on this, which is the minimum amount of time that you could possibly spend on an architecture document, okay, it's 3 meetings. It'll never be shorter than that. This won't matter. Work will be overcome and dead by then. So I would heavily, encourage you to make some forward progress on things that have already been discovered in architectures, proprietary architectures widely deployed, and figure out how to fix those given the various expertise we've learned from the different ways we did it and the different problems those architectures ran into, and just get it done.
Bernardo, just one point in addition to what Colin said. One thing about the proprietary arches, as far as I know, they've only tried to solve the temporal case. So in some sense, we're going a little beyond it here. And so we'll push the boundaries and see if we can do it or not do it. And we learn something in the in the process of why we can or can't. And we can write that down, and maybe we take another shot at it, or maybe we just decide to do what the proprietary ones did in the terms of scope and then leave it at that.
So chairs for 5 minutes. So do you want to ask for a call or not?
I want to inject myself, Magnus Westerlund, slightly about one comment from my personal view. It is continue working on this, but be ready for that. It might be additional requirements or something coming out of the other work. That's so.
So,
Nicole.
Yeah. So, I mean, I guess it sounds like, I sort of already asked the question. I mean, there was one objection, and but if you want to do a hum or whatever.
Well, we have 2 plus 1s on continuing on the agenda.
I mean, on doing the work or on plus 1s on what exactly? Sorry.
Just ask the question. Who knows? Everyone always thinks other people should continue working. I'm all in favor of that. Now, about working group documents.
Yeah. So, who supports taking on this as a working group item? Vote. Okay. So we have 10 plus people for. Anyone against? None. So
Well, none, but with a sort of disgusted head shake.
So confirming it on the list and then work with the ADs to create workup item. I guess it's the next steps here.
Okay. All right. Any other business, or we will see you in Yokohama? All right. Thank you. And reminder to Emil and Varun, send the chairs your minutes or the list if you think they're brilliant.
No. Too much